Hello, everyone. This is Abdurrahman Gilal. Um, Today, we will be discussing about object-oriented programming. As in our previous presentations, we discussed that we have got so many programming languages, and Java is one of the strong languages. And we also discussed that Java supports object-oriented programming paradigm. So, what is actually object-oriented programming? So, despite of knowing any language, so we will be discussing a bigger picture of object-oriented programming in this a short video. So let's start to just begin with that. For instance, as I told you in our previous presentation, that Java is object-oriented programming. So object is an entity. It could be a concept or any abstraction that is meaningful for a software system. For example, if you're talking about any event, if you're talking about human, if you're talking about animal, places, or any other object such as a football or any cricket ball or bat. So anything that we can see and that is actually the focus of our system could be considered as an object. So when I talk about object, I always say that it should be identified. It has to have a name to it. So you cannot just simply say that it is just an object. So it is a football, it is a human or any train or any car or any vehicle. So you should be having some name to it. And definitely, once we talk about any object's name, which means it has to have some values to it, or I would say properties to it, as well as some behavior. For example, if I am a human, so I have my name, my last name, my mobile number, my, salary, and there's so many things that I carry along with me. Exactly in the same way, the students. So student has a name, student has got address, phone number. So these are their properties. And we as a human or teacher or student behave at different occasions by using our properties. For example, I teach, you learn, and we talk, and we run, and we eat. So these are called, behaviors. So I would say identity is a name, state is the property state, and then behavior is action that we perform. So let's say if I talk about some Dr. Grace or Claire or any other doctor, they are different doctor and everybody is having a different name and different properties and they do different things. So sometimes the doctors, they operate, they diagnose, they prescribe the medicine. So there are some actions they do commonly. So when we have something that is coming as a common thing, so what we do in programming languages that if I see there are 7 billion people in the world, which means human, so we have to create about 7 plus billion objects. This is going to be very complicated. So what we do is that in programming languages, we see certain things, as I once again tell you, that name, states, and behavior. So what name, state, and behavior could be? So we consider that properties or names or behaviors combinedly into a class. So class is an app, is a level where we could see it's just a template by which somebody can extract objects. So if I have a class human or if I have a class medical doctor, I can extract Dr. Grace or Claire, anybody. Or if I have a class like a teacher, so it could be me, it could be Professor Peter, it could be Professor Wakas, anybody could be there, right? So keeping class as a template, and then we can extract objects from the class. So this is what we have to understand. So in order to design, I have come this way, but when we are already designed and we are developing coding, we can go this way, which means we design the class first, And then with the class, we can develop the objects. So let's say this is a set of, pictures. So how many classes do you see? If you ask me, I would simply count, start and say, okay, this could be a vehicle, this could be a vehicle, and this is a fruit, fruit, and fruit. Oh, this was vehicle too. So you see, like one class is the fruit class, and the second class is the vehicle class, and the third class is animal class. So we basically have three classes into it. So let's say, like, as I just told you, that we've got name, we got states or properties, as we got methods. So let's say there is a cat. It's the name of the class. So we are not saying anything about any specific cat, but we are just simply collecting the things that could be in a class. And we got some properties, like every kid has name, gender, age, weight, color. So everything that's there, which means these are some values that we assign to it. So when you see plus sign, which means everybody can see that, which means if you see minus sign, which means not everybody can see that. So there's some restriction over it. So this diagram that you see on your screen is just a UML diagram, Unified Modeling Language diagram, to represent a class. So don't worry if you don't understand that. Just try to focus the content that we are discussing. And then the last block, the first block is the name block. Second block is the field block, which we say that the values, the states, and the properties. And the third block is the method block, which is called behavior. So as I told you that once we design, then we see all the possible properties that could be part of the class. And then when we develop or we use them, we basically implement into the object. So let's say this Oscar is a cat. So Oscar could be a cat. What is the weight, the name of the Oscar, gender, height, age, color, and the texture. So many other things could come here. And what does the cat do? Maybe the behavior is sleeping, behavior is eating. So all these behaviors remain common between Luna and Oscar. It's the same thing that we just saw here, that Dr. Grace and Claire. So the behavior may be the same, properties may be the different. So this is how we actually replicate the design of the object into the object-oriented programming languages. So let's say that if I generally see a bigger spectrum, so let's say we got organisms. So let's say we have animal, we could be having plants. So in animal, we got a cat and dogs. So we can have a hierarchy, right? So let's say if I'm talking about animal, so animal may have the cat as a subclass or dog as a subclass. So it could be further divided. Like if I see a family hierarchy, which we may have the parent as the first one, and then maybe we be having child, and then a child may have another, a grandchild. So let's say it's just a hierarchy. I'm trying to make you understand that. So this properties may be shifted from one to another one. So let's say if we have a common property such as name, sex, age, weight, and color, but this could be considerably be used by the dog class as well as by the cat class. So such type of situations are sometimes called as inheritance, which means the subclass is actually taking some values and properties from the superclass, not only the fields as well as the behaviors. So it is how it looks like. So considering like overall spectrum of object-oriented programming, there can be several concepts within the object-oriented programming. But let's say what are the key important features of programming, object-oriented programming. So it is abstraction, polymorphism, inheritance, and encapsulation. We will be discussing each of them shortly, and we will be developing them throughout our course. So don't worry. And if you have any question at any place, just email me, text me, or leave me the comment. I will try my best to answer you back. So let's start with abstraction. So abstraction is just a model of a real object, and it does not have too many things. It may have some values into it, it may not have some values to it. So it is something that everybody can actually extend to. So let's say if I have a class like a like aeroplane class, so you're gonna see that the aeroplane have the seats. In any airplane that you go, you gotta get a seat, and sometimes you're gonna go for the reservation. So it depends that which airplane are you talking about. But if you're talking about some specific airplane, such as the fighter jets, so there you do not actually reserve the seats. So I would say they only fly. So every airplane flies, and every airplane has these common properties. So these are just the values, and these are just the behaviors. So that's where we commonly pick up the properties and then we keep them. And then any other class that comes, they may extend them or they may actually replace them as per their need. So sometimes this type of things, and when we are trying to extend the class, we basically may have inheritance or we may have polymorphism. So let's talk about inheritance first. With the inheritance concept, it is a very simple concept that I actually may have blood group of my mom or dad. So basically, I am just inheriting some features from my parents, may have last name from my parents. So things that are actually coming from the parent class remain common for the subclasses. So any class that want to just add on something, such as animals may have different, behavior of their, you know, talking or chatting in other words. So let's say the cat does meow and the dog barks. So this is not common to both of them. So I cannot keep in here. I cannot keep in animal class. So let me have this specific for the cat class. So in this type of situation, the other things the cat class is taking from them, from the animal, I'm sorry, the dog does the same. Dog class does the same. But we have a different behavior for dog and different behavior for cat. So the subclasses may have extension keeping the animal class in view. So superclass will be giving some values to the subclasses. So that is how we see the inheritance. So inheritance and the polymorphism sometimes look like the same because polymorphism says that the one thing may have different shapes. For instance, I give you I am teacher in the class or a student in the class, brother to my siblings, son to my parents, friend to my friends. So you see that one person, one object, or one entity is having different type of, behavior at different occasions. So this is what we call polymorphism. So, but when we develop the polymorphism in specific programming language, any such as Java or C++ or C Sharp, so we may actually behave or we may experience certain things common between inheritance and polymorphism. So when I say similar things, which means that we may encounter similar kind of coding. So we will be discussing in our course later on when this topic comes. But let's say here, I just give you an example that animal have every animal got some sound capabilities. So we say every animal makes sound. This is the behavior. So kid makes the meow and the dogs barks. So let's say here, when this class influences that behavior, so this is called polymorphism, which means this one will be influencing to change the behavior of animal class as well as this will be changing the behavior of the animal class. So in this type of scenario, when one class is, changing the behavior of another class or superclass, this may consider as a polymorphism. So, but right at the moment, you just understand that um, polymorphism is object-oriented concept, which says that one object may have different representation at different places, or one class may have different representation at different places. So how we will be developing in that's a case of the further weeks of this course. So let's talk about the encapsulation. So the word encapsulation says that the information or the behavior remain encapsulated, which means remain private or protected, which means that if I've got a banana, so banana fruit is covered by the skin. So the same goes with orange. So the actual things remain protected. So when we wanted to protect our data or our behavior of the system, so what we do is that we decide whether it's public or it's private. So if public, that means anybody can use us. If it's private, which means not anybody can use us, only the people to who we authorize, they can use us or they can call us. So in a nutshell, encapsulation actually helps us to to apply some sort of security to our stuff, right? So how do we do that? We will definitely be discussing later on in this course, but if you see in a bigger spectrum, that if you're talking about flying airports, so airports actually get some information of a helicopter, airplane, or some other sort of planes that are basically going to come and land at the airport. But this does not stand alone, complete the system. So the flying transport gonna be a one center point, which we call interface, and then these both will be discussing the properties as well as the behavior. I mean, both from airport as well as from the vehicles or type of planes to be landing here at this information place. So what is interface? It is can be considered as a type of a class which does not have some developed things into it. It is just considering some sort of definitions, which means some declaration. So that's all. So we will be explaining it later on, but encapsulation in a nutshell is something that actually protects the data or behavior of the system. So this is kind of a statement that I have given to you, and I ask you to read it or see it, pause the video, and identify what classes could come out from these statements. So I have already given you the explanation to it, but when you wanted to convert that object that is called doctor objects into a class. So how you do that? So every doctor may have ID, name, address, and phone number as with us as a student and teacher. And every doctor can insert some information or some delete some information in that particular class. So that's, I think, all. If you have any question, please do not hesitate to approach me, leave me a comment or email me. I will try my best to return to you as soon as possible. Thank you so much. Take care. Bye bye.